We're going to finish lesson 10.3, which was working with, first we did mean, median, mode, and range, and we're going to finish that up with talking about making box and whisker plots, and then we're going to go into lesson 10.4, which is misleading graphs, and we'll talk about what makes a graph misleading and what we need to look for when we're looking at graphs, and when somebody presents us with data on TV or on the internet now, then what does it mean, and how is it misleading information for us, and how can we check to make sure that they are not trying to just steer us in their direction. So first, making a box and whisker plot. So we've seen these before, you've made them. Reminder, what we need to do is we need to take our set of data, and we're actually going to divide our data into 4 pieces, into quartiles. And then we have what's called the interquartile range from that. So we have our whiskers and our box. When we talk about the interquartile range, we're actually talking about how wide the box is on our box and whisker plot. And so when we do this, the same as with the other ones we were talking about yesterday, first thing we're always going to do is we're going to put the data in order from least to greatest. And then we're going to divide it into 4 equal parts as far as the quantity of data that's in them. All right. So let's just go ahead and jump right into it. All right. So here we have the number of runs scored by a softball team at 19 games is given. And so we're going to use the data to make a box and whisker plot. And so what we're going to do is we're going to do this by hand as far as figuring out all the specific numbers we need. And then we're going to do it, we're actually going to use our calculator to help us in the process also. So I'm going to show you how to do that. All right, so first of all, we want to order them from least to greatest. All right, so now that we've got them in order, all right, we need to make a box and whisker plot, we need what's called a 5-number summary. All right, actually, I'm going to move that up here. Move this down. All right, and that 5-number summary is the min, the Q1, we'll talk a little bit more about that, the median, Q3, and the max. All right, we need those 5 specific numbers to be able to make our box and whisker plot. And so this is called a 5-number summary. And so whenever we make a box and whisker plot, those are the 5 numbers we're talking about. All right. Okay, so all right, min and max are the easy ones. All right, we got 3 and 20. All right, now, we know how to find the median. We talked about that yesterday. It's the middle number. So since there's 19 numbers, then I need to find the 10th number, because then there'll be 9 below it and 9 above it. All right, so we got 1, 2, 3, 4, 5, 6, 10. All right, so this 10 right here is the median. So what we've done is we've divided the amount of numbers I have in half. All right, and the middle number is 10. Now, to find the quartiles, we take each of those 2 halves and we find the median for them. All right, so I'm going to find the middle number now for this set of numbers and for that set of numbers. And that's going to give us Q1, which is the quartile, the first quartile, and Q3, which is the third quartile. So 1, 2, 3, 4, 5. So there's 9 of them. So it should be the 5th number here is Q1. And the 5th number over here is Q3. All right, so that's 6 and 12. So the median, middle number, the first quartile is the middle number of the numbers below the median. The third quartile is the middle number for the numbers that are above the median. So there's our 5-number summary. This is what we need then to make our box plot. Now, so we need a number line that gets us from 3 to 20. Right? And so whether you go by 2s like I did or whether you go by 5s, however you do your number line is up to you. Probably going to do by 5s, probably the easiest for you guys to do. So if you go from 0 to 20 by 5s, that should probably be good enough. But whenever you make a box plot, you always need to list these numbers, either like I did here, or at least somehow with when you make it, right? So our box plot, when we draw it, is always going to be above the number line. Now I see some students will put it on the number line, but it's supposed to be above the number line. Okay. So first thing we do, mark our min and our max. So we'll put a little vertical line here that represents 3, the min, and down here for 20, my max. In the box that I have then, for my box and whiskers, is going to go from 6 to 12. It's from the first quartile to the third quartile. So I'm going to draw a rectangle from 6 to 12. And then my median is 10, so I will draw a vertical line in the box for the median. All right, and then I connect these. Hopefully yours is in the middle. There we go. All right, and there's my box and whiskers. All right, so we find the 5-number summary. We mark our min and max on the number line, so above the number line. Draw a rectangle that represents the box itself, which is from Q1 to Q3. Okay. And then we put our median inside there. Now there's one last thing that we have, and this is called the IQR, which is the interquartile range. And all that is, it's the distance from Q1 to Q3. All right? So basically it's just how wide is the box, or how long is the box. All right? So we just do 12 minus 6. So in this case, the IQR, the interquartile range, is 6. That's one way the IQR is one way that they measure variability and talk about how spread out the data is how big that box is. If that box is relatively small, then the numbers are pretty close together. If it's big, right, then they're spread out. All right, so there's doing it the by hand way, all right, without my calculator. All right, so I'm going to show you how to use your calculator to do the 5-number summary. All right, so take out your calculator. And we're going to go ahead and do it with those numbers first. All right, so to use our calculator to find those 5 numbers, we're going to go, first of all, we have to put the data in our lists. All right, so to get to your list, we go stat and edit. Stat and edit. All right, so calculator. right? Then we'll type all the numbers into your list. So if you have numbers in your list like I do, first thing you do, go ahead and clear them. So if you go up to the list number, hit clear and enter, then they'll go away. Okay. So clear the list first of all, make sure it's empty, all right, and then start entering in those 19 numbers in the order. Okay, so once you get the numbers in your list, all right, everybody got them in there? Okay. Then we're going to go to back to stat again and over to calc. Okay. So then we're going to go from stat over to calc, and then we're going to do one variable statistics. Stat calc and then one variable statistics, right? So which is the very first one. Hit enter. Right? When I hit enter, then I get these three things show up here then. Our list number, all right, so we're using list 1. All right, if it's not list 1, if you look on your blue numbers here at 1, 2, 3, 4, 5, and 6, it does the list 1, 2, 3, 4, 5, and 6. So if you press second and 1, it would give you list 1, or second and 2 would give you list 2, and so on. All right, so we want list 1. And frequency, we're not doing anything with that, so we'll leave that alone. And then calculate. Now this screen gives us a lot of information. All right. So the first thing, x bar, is actually the mean of the data. All right. So, all right, that helps me. So if I'm trying to find the mean, median, and mode, there's the mean right there. The next one tells me the sum of all the values, the sum of all of them squared. And then these two things here talk about standard deviation, and we'll talk about that in Algebra C. Right? So then n represents the number of values I have. So I have 19 values, and then when I scroll down, there's my 5-number summary. So the min is 3, Q1 6, median 10, Q3 was 12, and the max is 20. So stat and edit, it puts them in our list, and then stat calc and one variable statistics then finds us the mean, and then the 5-number summary we can use to make the box and whisker plot. All right, so I want you to use your calculator then to find your 5-number summary to make a box and whisker plot for this set of data. So you can do them by hand or using your calculator, either way, all right? Completely up to you. I want you to have the experience of using the calculator just so you can see them. Now, one other thing, I'll take a moment just to show you this, is how you can actually, it will make it for you. The calculator will make it for you. Did you know that? The calculator will make a box plot for you. All right, so let's go through that process just for so you can see it. So if you go to second y equals, all right, that's our stat plot, okay, blue here. Second y equals, all right. Here's all of our plots, all right. We can have 3 different plots going at the same time. Select the first one, all right, and we're going to turn it on. All right. And this is where, when you go to your y equals and you see one highlighted, okay, that's because it's turned on. All right, now we want a box plot, and we're actually going to do the second one here. There's 2 of them. The first one will show outliers, okay? The second one doesn't, so we're going to do the second one. Okay. All right, so hit enter on that. And then if your list, X list is list 1, then you're good. All right, then just hit, now we hit zoom 6 to get our window to that standard viewing window, right? Okay. If we go to zoom and 9, it says zoom for statistics. All right. If I do zoom 9, then it makes a window that will fit my data, and there's your box plot. Okay. All right, so I'll go through that again. All right. So second y equals for our plots. All right. We turn it on, choosing a box plot. Okay. And then we can do zoom 9 will give us the right window for it. Now hit trace. Okay. Then if you hit trace, it will actually then trace your box plot for you. All right, so there's my median. If I go left, there's Q1, there's my min. Go to the right, there's Q3 and your max. Right. So your calculator will actually make a box plot that you can use also, which you don't necessarily need that, but you can access it. Okay. All right. Okay, misleading graphs. So we want to be able to recognize misleading graphs or recognize statistics that go with them. All right? So it's kind of like this cartoon here. It says, guaranteed not to break down while parked. Okay? Seems like lately we've spent a lot of money the last couple months on cars because they've been breaking down. Okay? So here we're just going to take a look at some graphs and determine why they're misleading graphs. And the biggest thing you want to look for, the main thing is you want to look at the y-axis. All right? So when we have like a bar graph or a histogram or a line graph, okay, you want to look at the y-axis because usually the thing that's misleading has to do with the line graph or with the y-axis. All right? So here we have customer satisfaction for 4 different brands of cars or something, right? It says brand A, B, C, and D. And notice that the scale starts at 76 and goes up to, looks like 86. Right? So why do you think this graph is misleading? Emma? Any idea? Anybody? So with this graph, why it would be misleading is the fact that it makes it look like brand B is really good. Much better than the other ones, right? Okay, because the bar is so much higher, it makes it look like brand B is better, right? Okay, and so, well, we answered this question. So what might someone believe because of the graph? All right, believe that it's a lot better than the other ones. Okay, but here's the thing. All right, so if we change this to go from, if it's a satisfaction survey out of 100, okay, and if we went from 0 to 100 instead of going from 76 to 86, all right, would it really look like there's much gap there between them then? No, it wouldn't look like there's hardly any at all. All right, so someone might believe that the brand B is a lot better, right? And who might want to use that graph? Who might want to be the people that put out that graph then? Ellie? Yeah, whatever brand B is, whoever's the owner of brand B or those selling them, those people are going to want to put that graph out and say, hey, our brand is so much better than the other brands. All right, you can see it on the graph that we're a lot better. You know, in reality, Comparing it to D, it's only 3 points higher. Okay, and when you're talking about out of 100, 3 is not very much. Okay, so it's really not that much better, but the owners of brand B are going to want that to be put out there. And so that's a big thing that happens with a lot of graphs, is they're misleading just because of that. Okay, let's look at another one. Here's a line graph. So like I said, the first thing you want to look at is the y-axis. And is there something going on with the y-axis that might make you think it's misleading? Zoe, what do you think? Can you see it?
Yeah, it goes from 50 to 45 and 45 to 40 and then it goes to 30.
Okay, so the y-axis is not consistent. All right, and if we're doing a y-axis, the y-axis has got to be the same. All right, so this is misleading because the intervals on the vertical axis or the y-axis are not equal. They need to be equal. Right? So because of that, then somebody might believe that there's really a big difference in the amount of rainfall in that area, that metropolitan area. And so when reality is it's not as much as they make it out to be, because they have a different, all of a sudden they change their scale, right? And we know that when we've made graphs, the scale's always got to be the same. Right? All right, so someone might believe the amount of rainfall fell dramatically from 1997 to 1999, when it probably didn't fall as much as they want to make it out to be. So who might care about that? Want to use a graph that looks like that instead of one that's normal? What do you think, Ellie?
People who care about the environment might spread it to say, hey, look what's happening, we might want to pay attention to it.
Okay. All right. People concerned about the environment. What else? Michael, what do you think? Okay. So since we're talking about a metropolitan area, probably the city officials who are concerned with there being too much water usage might be concerned about it, because hey, if we're not getting as much rainfall as we used to get. So now we need to be careful how much water we're using, so you can't water your lawn, all right, or something like that. Okay? All right, so another one. Circle graph compares each category of a data set to the whole. When any category is not represented in the graph, it may appear that another category represents a greater percentage of the total than it should. All right, so here's a county budget for 2005. All right, Sabrina, what do you see? Okay, our road maintenance, it says, is 25%, and according to what this looks like, that's over half of it, isn't it? All right, so they're showing over half of the data is 25%. So they're really making that 25% look big. All right, well, it would have to be more than 50% if we're according to that picture. All right. So what might someone believe by just looking at that graph then? Zach? You got nothing? Case? Josh, how about you? Okay. All right, so here it's budget, so not necessarily time, but okay. All right, so their money, most of the money will be for roads. All right. So who do you think would care about that? Would want that to be the case, that they're looking at that and they said, hey. All right. So it could be two groups of people. One is concerned about too much spending on roads and say, oh man, we're spending way too much on roads if we're spending over half of our amount, even though it's only 25%. Okay? Or it could be the road maintenance guy who's like, hey, we need all this money because 25% of our is this much, and so we really need it to have it to spend. Okay? All right. So there we looked at three different types of misleading graphs. All right, so you have to be careful looking at y-axis, what happens on the vertical axis, and if you've got a circle graph. All right. Okay. Statistics can be misleading because of the way the data is collected or the way the results are reported. A random sample is a good way to collect unbiased data. In a random sample, all members of the group being surveyed have an equal chance of being selected. So here, a study of 5 households found the following number of pets per household: 2, 1, 1, 9, and 2. Explain why the following statement is misleading. The average household has 3 pets. And this actually takes us back to the warm-up, when we were looking at should we report data by the mean, the median, or the mode. And so the one thing we talked about is if there's an outlier, okay, that makes the mean look bigger, or the mean is going to be bigger than, but does the mean really represent the data well? So in this case, the mean is probably 3, but that's more pets than most of the people have. And so in this case, they would probably want to report the median or the mode as that piece of statistic instead of the mean. Right? So why is that misleading? Because really most of the 4 of the 5 have less than 3 pets, so that really doesn't tell us the true story. Okay. All right. So be